technical concepts such as in-memory versus caching, and also what is architectural options. So like this, we have some few topics which we need to cover in the point of introduction to HANA. So these are the things which I'm going to cover in this today's session. So what is relational database management system, and what is in-memory versus caching, and also architectural options. So once this is done, so the introduction part will be completed, and I'm recommending so all the people just recollect these things. So all the functionalities, whatever we have discussed in yesterday's session and today's session. So here, when we are going to talk about the introduction part, so we discuss about the basics. What is the concept which we need to discuss with the basic concept of HANA system? We discussed in yesterday's session. When you come across with the continuation part, so here when we are going to work with the HANA database, here there is some few topics are there. So in the previous class we discussed with ERP on HANA and also S4 on HANA. Now we are going to discuss SAP, the HANA in-memory database management system, and also the in-memory versus caching, as well as architectural options. So these are the points which I'm going to discuss in this session. So in detail, let's come to the point. Then, number one. So the HANA and relational database management system. So what is the difference between these two things? The SAP is a relational database, but it has been described as re-innovation of the database. So this is nothing but the relational database only, but it is re-innovated in the whole SAP HANA database. It is true that SAP has a database in both SQL and also ACID complaint. That means ACID indicates that atomicity, consistency, isolation, and durability. So the SAP HANA as a database in both SQL and also ACID compliant. This means that you can run the most common and latest SQL command with SQL script. So ACID compliant means that the SAP HANA performs like any modern database system because it processes the transaction that follow a set of rules and conditions, maintain consistency of the transaction, isolation transaction for each other, and ensure any committed transaction won't be lost. And there are four guiding principles of database theory. So which is called atomicity, consistency, isolation, and durability. Because of this, where SAP HANA breaks from the relational database management system model, it is to be store all the transaction in memory first and in columnar data format, and then it will compress the data so to make the disk space free. And many in-memory database available on the market in today requires you to store the data within the disk based database first, and then it replicates to the main memory cache. With SAP HANA, end-user transactions are read and written from the memory first and then synchronized to the disk and committed to the log. So that means there is some architectural changes there in this case. The SAP HANA is open and support open database connectivity, which is called ODBC, Java-based connectivity, multi-dimensional expression, OLDB for OLAP, and also the .NET functionalities with ABAP extensions. So these provides the external access to both the database and its application platform. So that means, so in simple words, you can say in existing ERP, when you take RDMS, relational database management system, so here any that means it will record the transaction in the form of row based architecture. Every time whenever you create a new record, it stores the information in row base, and it takes lot of disk space to update this information. Every transaction is get updated with a new record, so it takes a lot of disk space. But here, so it is updated with the columnar format, and also it will update every information within the system. So that is the reason, so the disk space is very less compared with existing ERP. Then SAP HANA is an enterprise platform because it offers a database and an application platform that provides advanced text analysis and spiral reference, virtual OLAP, and a web application server, and an advanced data replication engine, which is called SLT, System Landscape Transformation. So it's an entire application stack in one system. That means no need to take the different types of installations in different levels. So all the things are within the system in HANA database. So that is one of the advantage. You can deploy a web application running SAP Fury on SAP HANA platform, leverage of all the components, and only need to maintain in one system. With other software vendors, that this might be requires two or more different systems. That means, say for example, if you are taking in any other different software, Fury system is different, HANA system is different. So like this we need to consider. But with in SAP HANA, once it is upgraded to the S4, so it consists of all the information whatever we require, such as the cloud platform, so or else NetWeaver platform, or else so the HANA database. So everything within the system, it consists of all the information. So that means the advantage here is the integration between these systems is also so easy without connecting to the different systems. The SAP HANA also offers the disaster recovery and system replication features. That means disaster recovery means if any power failure is there or any unexpected circumstance, if the server is suddenly shut down, so in this case, what happened to the data? So there is some precaution need to be taken. So this precaution is taken in disaster recovery management. So that means the HANA offers the disaster recovery management. And number two, system replication. So system replication means the data need to replicate from one database to another database. Say for example R3, you have a data in the R3. So now the system need to replicate this R3 data into the S4 HANA. So there is a certain features are there within the system itself. So you would expect from an enterprise platform. All these things are possible only from enterprise platform. In the previous class, I told you, with the enterprise platform, only it is possible to update all the things in one database. So you can replicate within the data center and across the multiple geographical disappeared data centers. It also support the configuration with GUI in SAP HANA Studio. Then, additionally, the SAP HANA is available as a both cloud and on-premises platform. Yesterday we discussed, somebody has asked me this question. So whether we are going to use cloud or on-premises, it is a combination. So here the SAP HANA is available as a both cloud and on-premises edition. So most of the customers, they you have a choice to choose whether you want to work with on-premises edition or whether you want to work with cloud edition. But here the recommended action is you can choose to run SAP HANA in hybrid scenario or use services from SAP and its partners, which offers the SAP HANA as a platform services, which is called PaaS, in addition to the traditional infrastructure as a services. So this is the basic thing that what we understand about the database. That means now let's come to the important point, which is called in-memory databases, in-memory database versus caching. What is the in-memory database? What is caching? So here, an in-memory database means it's a different from data in memory. So that we already know. So the IBM first database is in 1968, which has the ability as a customers to run the database that could pin the tables to memory. So a commit operations would exist at the disk level and process would copy the data into the main memory. This is often referred as disk block cache. So that means the commit management would be exist in the disk level. So every information is being updated into the disk level and process the copy to the main memory. So then it will update the information into the main memory. So this is called the disk block cache. The industry term in the industry term is in-memory database management system, which is called in short form IMDBMS. So was coined to describe the database that stores the entire data structure in memory with all the operations such as select, insert, update, and other functionalities. This will be occurred in memory without the need of input and output instruction to the disk. That means simple. So here we are going to use in-memory database management system. So in existing ERP, the data is being updated to the hard disk and from the hard disk to memory, after memory to CPU register. But here, what the system will do is, the system will update the CPU register first and then it will store the information in memory, which is also called as RAM in simple words. So then the hard disk is completely free. Whenever the hard disk is completely free, the system performance will increase. Like this, the structure has been designed. And the BW extractors is the best example for the database in memory. So we can load specific data from BW content, that means BW server, into the main memory of any other server, which would be used for OLAP operations, that is only for the read access. It could be the index of the tables or group of index, but the main point here is that the database which catches the data in memory was not used for OLTP workload. Then SAP HANA is a in-memory database management system that use the columnar store. Columnar store means column-based storage, and the multiple comparisons, logarithms, and also to store the entire database in memory. And it works closer to Linux system to manage the in-memory and also correctly allocate the memory tools for the most efficient storage of the data. So now most of the people we have a question. So here what happened to the compressed data? So here when we are going to think about the compressed data will move into the SAP HANA. So that is completely updated within the system with the index tables. And the main feature of the SAP HANA is it manages the tables and also it determines the compressed algorithms in RLE structure to be used in the column store tables. Multiple columns within the table in memory could use different comparison types, and also not in all the columns are loaded in the main memory. Sometimes it is referred as lazy load. And SAP HANA loads column into the memory on first use. So columns are then updated into the load structure, then it will update the memory. So the advantage here is, so it saves lot of disk space. So that is the reason the memory wastage is not there. The SAP HANA is a collection of process to the operating system which request main memory data structure from OS based on demand when the virtual memory needs to be used in mapping of physical memory of reference memory. So that means, so here the data will be updated into the column store and the column store structure is updated into the in memory. Whenever the data is being updated into the in memory, so you can save lot of disk space. So the OS, the operating system, uses an algorithm to swap the old process out of the reference memory. However, it is correctly sized for SAP HANA system, which will not occur in the previous. The SAP HANA memory manages with request the reserve more memory for OS. By default, SAP allocate 90% of the first 64 GB and then 97% of the remaining memory. So these allocation limit can be changed in scenarios when you create the multiple SAP instance on SAP platform. So that means, so it takes very less disk space and also it will update every information so within the system. The SAP HANA has a matured. SAP has provided its customers with the tool that need to manage the memory in platform. You have the commands to load all the tables into the memory to get the worst case, the measurements, and also you can take the snapshot of this memory usage over a period of time. So that means the in-memory database will give the complete picture. So and also it stores very, it will compress the data into the columnar store and it will store the information by taking a less memory power. So that is the reason. So that performance will increase automatically. The SAP HANA, SAP ERP and S4 HANA to monitor the disk space in HANA database. All the transactions are written to the data and log first files too. So if you see here the screen, so the virtual memory, so free memory, workspace, and the tables, and also the SAP HANA coding block. But when you come across with the SAP HANA used in-memory database, so it takes workplace, table structures, and also the coding block. So this is the difference between these two things. That means why in-memory database? In-memory database means simple. Every information, whatever it is, gets stored in the RAM is known as in-memory database. That means previously in existing ERP, once if you create any record, this will be get updated directly into the CPU register, CPU into the hard disk, from the hard disk to the memory, and from the memory to CPU registered. But when you come across with the HANA architecture, so here that's totally opposite. So now here it will update into the CPU registered. After that, it will update into the main memory, which is called RAM, and the hard disk is completely free. So this is the structure which is updated here. Then, so when you come across with architectural options, so here this is very simple to understand. The SAP HANA supports a point in time recovery with ability to configure the high availability and disaster recovery management. As I already told you, so most of the people has a question. So technically, if you think, so suddenly if the power failure is there, or else any inconsistencies occurred, so what happened to the updated information? So this they had given they had updated a solution for this structure from local disaster recovery to site replication. So SAP has delivered out of box functionality to support most scenarios. There is no additional license to buy to leverage this advanced feature. So separate license is not required to run disaster recovery management. So SAP HANA as a database has two options. One is, so if in the database structure, the SAP HANA can deploy the scale up to the scale. That means there are two things are there, scale up and scale out. There are two scenarios are there. With scale up, we deploy as many resources as possible to a single host to support the current database and features in database growth. So with the scale up, we can deploy many resources as possible to a single host to support the current database. So please remember this point. So with the scale out scenario, we add additional SAP HANA host along that side, the primary host to add additional capacity for the database to grow. The scale out scenario, data is distributed among the host and supporting to the database. We have to plan for the manage this data distribution. In scale up scenario, all the data reads within one host, which is the easier to manage the SAP business suite on HANA is only supported for scale up scenarios. That means the SAP, there are two things are there, scale up and scale out. So if you take scale up, any information, whatever we are giving as an input, so this will be get updated into the within the system, and also the additional capacity of the database growth will be get updated. So the advantage here is it supports all the internal structure within the system. But when you come across with the scale out scenarios, so in this case we need to take the third party system to store the information, so for any disaster recovery management. Currently you have a single stack with the above application server sharing with the same host on the database, or you might have a separate clustered primary application server with standalone dialog server and clustered database. So here you see, so there is a structure is there. So here the SAP production environment, disaster recovery management. Production environment is different, disaster recovery management environment is different. So the production, if you take scale in, so in this case, both systems are consolidated every time, every minute. But when you come to the scale out, so this disaster recovery management need to be maintained in a separate system. So at this moment, so whenever that any power failure or any other data disturbances get updated, so that relevant information will not update directly into the HANA system. So that is the reason here there is a small changes is there. Small to medium enterprise customer can run the SAP business suite on HANA in cost effective manner, and still it get recovery point objectives and recovery time objectives. That means a small and medium customers also they can run the SAP HANA with cost effective. So then when we come across with recovery point objectives, you can update every information with minute to minute into the system. The SAP can handle the automatic host failovers, all the database layers. The above application server failover is manual and requires DNS changes, but it can be executed in under hour or even 30 minutes if it's well scripted. That means within 30 minutes or 1 hour, we can take every information as a backup information, even though there is a power failures or uh, any other issues happen in the database architecture. This assumes that you are using SAP Solution Manager to monitor the system availability. So manual process can be started in the event failure. That means we have a solution manager structure is there. The solution manager is always connected to the HANA system. So any problematic issue is there. Once you update the solution manager, so even though the any event failures occurs in the HANA database, the solution manager gives the information again back and it will update the information. In terms the system replication types, which can be used in multiple strategy, and you can update these multiple strategies in different levels, such as asynchronize, synchronize in memory, synchronize, and also synchronize in full version. So asynchronize. The primary system commits the transaction after sending a log. Say for example, suddenly the power failure is there. So the primary system commits the transaction after sending a log without waiting for the response from the secondary system. This mode is most useful when the secondary site is more than 100 km with the primary site and or reducing the legacy into the system itself. Then synchronize in memory. So one second. Here you can see the structure. So here you can see synchronize and asynchronize. So in the first step, you can see the application server, so which the data will be shared that every information, and in the second layer we can find the HANA server, so which stores every information and it gets synchronized to the local standby. So every information is get updated here within the system itself. So then, synchronize in memory. The primary system commits the transaction after it receives a reply that the log was received by the secondary system, but it before is updated. The delay in the primary system is shorter because it only includes the network transmission time. Then synchronize. The primary system waits to commit the transaction until it receives a reply with the log in prescribed secondary system. This mode granted the permission with immediate consistency with both the systems and at the cost of delaying the transaction by the time of data transmission and pre-string into the secondary system. So synchronization full version. Another option determines that what to do the replication failure due to the network or system issues. These options are fail to the transaction and commit the transactions. That means there are four methods are there which the data will be recovered and also it will update into the secondary data structure. So like this we have some few features which is the part of this introduction to HANA. That means number one, we understand about the functionality of what is ERP on HANA, and number two, we understand about what is the difference between HANA and S4 HANA. So then we discuss about the SAP HANA and relational database management system. What is the difference? And also in-memory database versus caching and architectural options. So these are all basics only. So once if you understand these points, it is easy to understand about the project scope. So in the next step, these are all just revised one time. So just for your knowledge purpose, these things are there. But we are not working on all these functionalities and we are not seeing any of these functionalities. So our main target is S4 HANA Finance. Okay. So here, now if you come to the project scope, this is very easy to understand. Because the thing is here everything we can see in the live, so from where the data is going to pick and what is the supporting packs, what is enhancement pack, what is unicode versus non-unicode version. So like this we have some features are there, just we are going to take one overview because it's very easy to understand these points. So once it is done, so you are in position to understand. So if the technical people is going to update the technical deployment, so what you need to suggest to them, so based on the project scope you can suggest to them, so what we required and what is the expected value we are going to expect from SAP HANA Finance. So this I am going to explain tomorrow, and once it is done, so then I am going to discuss